Hello there and welcome to A2 Maths from Specimen Paper 2, and here we're looking at question 10, an integration question to do with parametric equations. So figure 4 shows a sketch of the curve C with parametric equations x equals ln t plus 2 and y equals 1 over t plus 1, where t is a value bigger than minus 2/3. Part A is state the domain of the x values for the curve C. Well, I know that ln is an increasing function, so if I just plug in my value of t, I'm going to have ln of minus 2/3 plus 2 is equal to ln of 4/3. Now, given that ln is an increasing function, as I increase the value of t, the ln function is going to increase as well, so therefore I know that x is safely going to just be bigger than ln 4/3. Okay, so there we are, that's the answer to part A, that's the domain of the x values. Moving on to part B, the finite region R, shown in the shaded region in figure 4, is bounded by the curve C, the line x equals ln 2, the x-axis, and the line with the equation x equals ln 4. Use calculus to show that the area of R is ln 3/2. Now, when you're integrating with parametric equations, you need to integrate between your t limits of alpha and beta, the expression for y, times dx by dt times by dt. This is the bit of the A-level course that's not in the textbook, but you do need to know this formula off by heart for how you would find a region with two parametric equations. Now, just a reminder, these alpha and beta values are in terms of t, whereas we know that these two values here are in terms of x equals ln 2 and x equals ln 4. That's not what we're looking to put into the boundary. But we know that the equation of x is equal to ln of t plus 2. So what value of t do we have to use to make ln 2? Well, we have to use the t value of 0. You can think about it, when t is 0, ln of 0 plus 2 is ln 2, which is exactly what we want. Another way of doing it for the ln 4 variety is to just set up a little basic equation of ln t plus 2 equals ln 4, and you can quickly kind of spot here that your t value needs to be 2 just to make the inside of the brackets equal 4. And then we're going to integrate the equation with y, so that's going to be 1 over t plus 1 times by the differential of the x value, which is ln t plus 2. So differentiate this, we get 1 over t plus 2 dt. Now, what we've got here are two fractions that are being multiplied together. I'm thinking what we need here are partial fractions. Now, in this case, you can kind of quickly spot the partial fraction is going to be 1 over t plus 2 minus 1 over t plus 1. You could do it the long way. I'm sure that you'll be fine doing it the long way round, but you can kind of see, no, the other way around, sorry, the 1 needs to go here and the 2 needs to go here. You can kind of see how this is going to happen. The t plus 2 is going to be multiplied up here, the t plus 1 is going to be multiplied up here, the t's will subtract and cancel each other out, 2 take away 1 is 1, which is what we want to have on the numerator. So this is going to be the answer in partial fractions. Let's now move on to the next bit. We're now integrating between 2 to 0, 1 over t plus 1 minus 1 over t plus 2 dt. Let's now do this integration. We're using the ln rules for integration here, so it's going to be ln of t plus 1. The ln rule is, does the bottom differentiate to make the top? Yes, it does perfectly. Take away ln of, again, the ln rule, does the bottom differentiate to make the top? Yes, it does perfectly. So we can use the ln rule. So it's going to be ln of t plus 1 minus ln of t plus 2. Let's now substitute in the values of 2 and 0. So it's going to be ln of 3 minus ln of 4. And then we subtract the other value substituted in, which is 0 ln of 1 minus ln of 2. And now we're going to put this all together, so it's going to be ln 3 minus ln 4. Ln of 1 is just 0, so that will just cancel out, and then expand the brackets, it's a double negative, so it's going to be plus ln 2. Let's add the two, let's multiply the two negatives, so let's multiply the two positives first, because that's following the ln rule, so it's going to be ln of 6, and then when you subtract a ln, you divide inside the brackets, so your final answer here is going to be ln 3 over 2. Lovely, so there we are. That was a really tricky question there involving a lot of integration rules. The first rule was this here. You do have to memorize this going into the exam. If you're integrating a parametric equation, then this is how you find the region beneath the curve. We then had to use a technique of partial fractions. I did it just by spotting it. If you can do it by hand, then that's fine as well. It might take it a bit longer, but try and spot it if you can. And then it's integration rules by the ln rule, and then substituting in and cancelling out lns and simplifying lns where possible. Wow, so there we are, 9 marks for that question 10 there. Let's now move on to question 11.